In this video, I will be answering 5 data analysis questions using Pandas, which is a really powerful tool in organizing, formatting, or answering real-world questions like these for a given dataset. As for the dataset, I will be using the animation series CSV file which I acquired from Kaggle. I will leave a link to this in the description below, and I recommend you to download this and follow along with me. Also, I will be using Jupyter Notebook for the purposes of this video. With that said, let's get into it. Okay, so this will be the notebook that we will be working on, and I'm just going to call this media analysis. So first I will start with importing Pandas as PD, and then I will start to load my data. And over here, the first thing that we will need is the file path itself. You can just copy that and paste it here in a string format, and then use 2 backslashes or the /. I'm just going to use 2 backslashes for here. And not to mention, if you already have this file path in the directory where you have this code file, then you can just type in animationseries.csv like that. And what I'm going to do now is create a data frame. For now, you can just imagine this as a variable which stores all of our data. So first I'm going to call this as df, and I will type in pd.read_csv, and I will pass in the file path. What this does is it reads the CSV file onto our data frame. So when you type in df.head, which just displays the top 5 records or the first 5 records of the data itself. So when you run this, you will be able to see the first 5 records of our dataset. All the 11 columns are available as well. So what I'm going to do now is something known as data cleaning. What this means is just basically removing all of the unwanted values or the unwanted records, or just organizing or formatting the data according to our needs. For example, in the gross revenue column, we see a bunch of none values. We don't really need this as none values. We can just replace this to a string which says data is not available. So to do this, first we will need to find all of the none values present in each column. What I will do is df.isNA.sum. So what this does is, if a column contains a none value, then isNA is going to return true, and then this sums up and gives us all of the none values present in each column. So basically what this statement does is it will return none values present in each and every column. So when you run this code, you will be able to see that title has no none values, whereas cast does, 127. So instead of having this as none, I'm just going to replace this to not available. First, I will access the cast column, df cast, like that. So you're accessing this cast column, and then over here, I will make the changes, typing in fill NA. This basically instructs the code to fill all of the none values with the thing that I'm going to give you, which is not available. Again, you will also have to type in place equal to true. This makes sure that the changes actually takes place in the data frame itself. So if you don't type this, then the changes won't take place directly and it won't be saved. So when you run this code now, let me just control it and paste it here. Now when you run the code, you should be able to see 0 none values over here. As you see, cast has no more any none values. And I'm also going to do the same to runtime, just making it to 0. So I'm just going to copy this and paste it and change this to runtime and make this to 0. Shift enter. And when you see this, runtime is not going to have any none values, neither does cast. And I'm just going to have certificates as none and gross revenue as none as well, because we will really need that. And also one more thing I want to mention is when you type in df.50 or df.10, it's just going to show you 10 records rather than the default 5. So when I type in 50, it shows us top 50 records. And then also one more function that I want to show you is tail. This displays the bottom 50 records as well. So as you see, these are the bottom 50 records. But then this also has the default value is 5. So when you run this, you will see the bottom 5 records. Nice. Another thing that I wish to do is, rather than having this as the entire string of number of words, I'm just going to change it to something like this. df.no.words. Like this. So since this does not already exist, it creates a new column named number of words, which is just going to be the same initial number of words. Like that. And then we can delete the original number of words by using the drop function. df.drop. And then you will have to mention the columns, which is number of words, Also, we will have to mention in place equal to true to save the changes like that. Now when you type in df.head, we see that there is a new column created, number of words. Also, I want to reorder the position of the columns to its original order. Like for example, when you see here, number of words comes before gross revenue, which is what I'm going to try to achieve over here. So to do this, what I will do is create a variable named calls and then create a list of all of the df columns. This returns a list of all the columns and then it's stored in calls. Now what I will do is create another variable known as order, and over here we can do the slicing method. To get the correct order, we will just have the first 9 columns as it is, and then we will need the last column and followed by the 10th column, which according to indexing will be 9. And also you'll have to remember that these two is going to be returned as string, so we will have to convert this to list, only then we can concatenate. Just going to do it here and here as well. And then now the updated df will be df of order, like that. Now when you run this code, oops, I will have to run all. Now when you run this code, you will see that number of words is before gross revenue, like this. Okay, so that should do it for data cleaning. Now I will be answering the first question, which is just classification of series and movies. This will ask us to create a new column which tells us if the record is a movie or a TV series. So the one way I see of achieving this is by looking at the certificate column, and over here if it has something to start with TV, then we can concur that this is going to be a TV series, else it's a movie. So it's that simple. That's the logic that we're going to go after. So I will do this by first creating a new column named type, which will be, and we are going to apply changes and we're going to use logic on the certificate column. So first I will be accessing that column, certificate, and then I will be using apply function. So what this does is first it takes in a function, and this function will be applied to certificate. For example, let's just first define the function itself, which we'll be using. Let me just define function, and then it takes in x, and if x.split, let's say when we split this by the hyphen and check for the first index, then we should be able to get TV. If we're able to get TV, then it's a series. So that's what we're going after. So split this and use 0 like this, which should be equal to TV, like that. Then return series, like that. Else, actually I have to define this as an if condition, like this, and create else column, and return movie, like that. So what this does is the function that we just created is going to be applied to certificate, but we also have to make sure that the certificate column only contains string type. So because split function only works on string, we actually have 2 ways to do this. One is by using the as type conversion, like this, as type str, and then apply, or we could just make this string like this, but I'm just going to use the as type str. And now when you actually print this df head, let's go 50 columns and then run every cell, you will see a new column like this which says that this is a movie and this will be a series. Nice. Okay, so the next question will be, which movie or series has the longest runtime? Again, when you look at this carefully, it says movie or series. So we just have to find one value that can either be movie or a series, just has to have the maximum runtime. So the way I'm going to do this is first I will look at the runtime column, and over here I will extract the first 3 digits and see which one has the maximum value, and rather than extracting the maximum value, I will extract the index which contains the maximum value. Again, this will make much more sense when I'm actually typing out the code. So to do this, I will define a variable named runtime nodes, which will contain the index of the maximum value. To do this, I will first have to access the runtime column, because that is where we will be applying the logic, and we can use the apply function once again and define the function. like that. So to define this, I use and takes in x parameter. In return, actually the way I like to do this is by extracting the numbers using the split function, because split by default only splits through the spaces, and we can access the very first index which will give us the numbers, and we can convert that to int again. So x.split 0, and then we can get this as int. Integer. Now I will run this code. Do you see that it's working until now? And it doesn't. So it says that it finds numbers like this, which contains a comma at the center, which we will have to throw off or just extract it and replace it with something. So to do this, I'm just going to use the replace function and replace the comma with an empty string like this. Now we should be able to convert this to int, and yes, we only get the numbers over here. Now what I will do is convert this entirety to a pandas identifiable data frame or an object. So to do this, I will type in a function named pd.toNumeric like this. So what this does is it converts this entire list into a series or a data frame. Only then we will be able to use a pandas function, which is idxmax, to get the maximum values index. And now we can use df.loc. This is a function which is used for slicing through rows and columns. We will first have to mention the rows. Now since we have the index, I'm just going to mention the index itself. So in this row we will need to specify what columns will we need. I'm just going to put this inside a list. We will need the title and the runtime as well. Now when you run this code, idxmax is not defined. Actually, we will have to put in a dot over here. Now, okay, again, we will have to use square brackets over here. Hopefully, yes, it does. So it gives us the title and the runtime and the maximum value as well. Nice. So the next question will be extract only the actual release year from the release year column in the dataset. So what this is trying to say is when you actually have a look at the release year column, you will find that it has the release year and it says it is going up to present. And some of them will have the release year and the end year as well. We don't really need that. The question asks us to extract the release year alone and then update the release year column. So to do this, it's actually, rather than using the apply function this time, I'm going to use regular expressions. If you haven't heard of it, I recommend you learn that. It is a really powerful tool to extract any data using patterns. But for the sake of this video, I will be explaining the pattern that I'm using. So the updated runtime will be the original runtime, and then I will convert this to str, and then from here I will use a function known as str.extract, and inside this I will first mention r, which is kind of an indication that we're going to use regular expressions, and inside this I will type in /d and 4. This actually is going to try to find the pattern which contains digit, and it has to be consecutively for 4 times. So we're trying to find a pattern which contains 4 digits consecutively, and we're trying to extract that as well. So actually when you type in, for example, 1,3 and then a point, then you're trying to find a number which has either 1, 2 or 3 digits before a decimal point. So that's how this works. It just goes on, but what we're trying to achieve is just finding 4 consecutive digits. So I'm just going to do this, and then I'm also going to type in expand equal to false. So this will make sure that the extracted data won't come out of the data frame itself. It just updates into there, and so we actually have the updated runtime. So when you now print runtime, okay, so we're not going after runtime, we are going after release year. Release year, and a year as well. And release year as well, like that. Now when you run this, it says pattern contains no capture groups. Okay, I forgot to mention that you will have to put this inside a parenthesis like this. Now we should be able to see the extracted column. Yes. So we're only saying the release year alone. even for the ones which did not contain the release year alone, it also contained the end year. Nice. So the next question will be change the runtime to hours and minutes. So instead of having this as only minutes, we're just going to convert this to hours and minutes. So the way I'm going to do this is first extract this and then convert this to int first and then divide this by 60 to get the quotient, which will be the number of hours, and also get the remainder as well, which is the number of minutes, leftover minutes. So the way I'm going to go with this is by creating two dummy columns, one for hours and one for minutes. And then finally I will concatenate that to the original runtime. Runtime will be df of hours with a space in between, and then df of minutes. As for the hours and the minutes column, it's just the same statement that we used over here to extract the digits. I'll just copy it right around. Actually, we don't need to use this pd.to numeric, so I will copy this and then remove the pd.to numeric because you're not finding the idx max function. Oops, I have to control C this. Control C, and then paste it here and here. And since this will return us the string because we changed it over here, this will only, okay, it doesn't, it will return an int. So we don't need to convert this to as type integer, so we can just directly divide this by 60 to get the number of hours, and then divide this by 60 again to get the number of minutes. Also, I will add in the hours word as well to make it look like the exact way we want to. Hours as type str plus hours, like this. Now we'll copy this, paste it here, change this to minutes. Now we can just simply drop those two columns. df.drop columns equal to hours in place equal to true. Copy this and then simply change this to minute as well. Now when you run trying to print the runtime, nice, so it does return what we want, and rather than having this as 0 hours, I'm just going to have the minutes alone. So to do this again, I will be using replace function. So df.runtime, since this is already, actually we are updating this. So since this is already a string function, a string type, so I will be using str.replace directly rather than converting this because a string data type. 0 hours to just an empty string like that. Now when you run this code, oops, actually you'll have to run all. Yep, so we have hours and minutes for those which actually has a number, and if it doesn't have any hours, then it only contains minutes. Nice. Now that this is done, there is one thing that I want you to know, and that is this df.log function is really powerful in terms of indexing or just slicing out the records that we want to. It can not only have this type of a format, but also it can have conditions, and it can also assign values to columns if we want. So this is what I will be laying emphasis on. I will be laying more emphasis on df.log function in the next question, which is, what is the total gross revenue generated by all the movies in the dataset? So first, when you have a look at the dataset, right around here, it says in the gross revenue column, there is obviously going to be none values for the movies that were released this year, that is 2023, and also gross revenue is not going to be available for the series type. So what I'm going to do is first I will access all of the records which contain gross revenue and then put them in a variable known as revenue. For our revenue series, it will be df of gross revenue, only which are of the type movie and they were not released in 2023. So I will use the log function, and over here the first condition will be df of release year must not be 2023. Just to be safe, I will type in as type str like this, and make sure to put this inside parentheses because I will be declaring another condition to check if the type is a movie or not. df.type should be movie, and instead of putting in the and notation, the thing that should be used in pandas is ampersand. And if you want to put in or, you will have to use this one, and if you want to put in not, then this one. So for our case, ampersand is going to be the one. And let me just run the revenue column. Actually, this is a series, and over here I see commas, so we will have to replace this. Will be revenue.str.replace commas with empty string, like that. Now when you run revenue once again, yep, so this looks like a number, but it's actually string, so we will have to convert this to actually this is a series of strings, so we will have to convert this to a pandas integer object. So will be pd.to numeric once again, and we will mention revenue. Revenue print. Yep, so now this is pandas identifiable series object. So what I will do is find the sum and then print it. So this is the entire revenue for series. Let's just put this inside the print. Total gross of movie. And close this, and now run this program. Oh. Yep, so nice. In the next video of this data analysis series, we will be exploring Matplotlib, which is used for data visualization on a large scale. I will link it on the screen once it's released.